Congratulations for clicking on this video because I'm going to guide you through most likely question you are going to expect in this forthcoming JAMB 2025 on lenses. With no further ado, let's get right into the video. An object 1 centimeter high placed on the axis 15 centimeters from a converging lens falls an image 30 centimeters from the lens. The size of the image is what? Option A 0.5 centimeters, option B 1.5 centimeters, option C 3.0 centimeters, option D 2.0 centimeters. The first thing that will come to your mind is magnification. Magnification is equals to image distance over object distance, okay? And it's also equals to height of the image over height of the object, okay? Now let's set our parameters. We have an object 1 centimeters high, right? So that is the height of the object is equals to 1 centimeters, and it is placed 15 centimeters from a converging lens. Now the object distance is 15 what? Centimeters. Now it forms an image of 30 centimeters from the lens. So the image distance is 30 centimeters. Now what are we looking for? We are looking for the height of the image. So you can say height of the image is what we are looking for, okay? Now using magnification formula, which says that what? Image distance over object distance equals what? The image height over object height. So going by that, we have that what? My image distance is 30 divided by what? 15, then is equals to the height of the image over height of object, which is what? 1. Simply by saying cross multiply, you say cross multiply, the height of image is equals to 30 multiplied by 1 all over what? 15, okay? Now let's cancel 15 into itself 1, 15 into 30 is going to give me what? 2. Therefore, the height of image is equals to 2 centimeters. I hope that is clear. So if you have this type of question, this is how you are going to solve it. So the correct option to this question is option D. A lens of focal length 12.0 centimeters forms an upright image 3 times the size of a real object. The distance between the object and the image is what? Option A 8.0 centimeters, option B 16.0 centimeters, option C 24.0 centimeters, option D 32.0 centimeters. This question says a length with a focal length of 12 centimeters forms an image 3 times the size of an object, okay? So let's just analyze it and be able to calculate what you're asked to. So listen up. You say a lens has a focal length of 12 centimeters and forms an image 3 times the size of an object. That means magnification is equals to 3. Now mind you, anytime you hear this kind of statement, forms an image 3 times the size of an object, it simply means that that is your magnification. And remembering that magnification is image distance over object distance, that is V over what? U, right? Now if you say cross multiply, my V is equals to 3U. Is that clear? Now what are we looking for? The distance between the object and the image. Now let's go. Using our lens formula, which is 1 over F is equals to 1 over U plus 1 over V, right? Now what do we do next? Let's substitute into what we have by saying that 1 over my F is what? 12. I have 12 is equals to 1 over U plus 1 over my V is 3U, 1 over 3U, right? So let's go. You say 1 over 12 is equals to, what's my LCM? My LCM is what? 3U, right? So this into this is going to give me what? 3. 3 times 1 is 3 plus, and this into itself is what? 1. 1 times 1 is what? 1. So what do we have? We have 1 over 12 is equals to 4 over 3U, right? So let's do cross multiply. So let's work it out by saying 3U multiplied by 1 is equals to 12 multiplied by 4, right? This is going to give me 3U is equals to 12 times 4 is what? 48. So by the time we divide by what? By 3, what will be my u? My u is equals to what? 16 centimeters, right? Now the question is, now my u is 16 centimeters. So what is my image distance? My image distance is 3u. That is 3 times 16 is going to give me what? 48 centimeters. Okay, now the next we are going to do is to get the distance between the object and the image. So that's the difference between them. So we can say that this is v minus what? U. That is 48 minus 16. Okay, then the answer is going to give us what? 32 centimeters. I hope that is clear. Now this is how to solve this particular question. We have to get our magnification by saying that magnification is 3, right? Is equals to v over u. To get our v to be 3u, now we now substitute into the formula using our LCM. Then you make it the subject to get our u to be 16 centimeters. But knowing that image distance v is equals to 3u, so you have to work it out to multiply to get my v to be 48 centimeters. But the question says the distance between the image and the object, so we have to subtract to get our answer as 32 centimeters. I hope that is clear. Now from what we have gotten so far, the correct option to this question is option D. A thin converging lens has a power of 4.0 diopters. Determine its focal length. Option A 0.25 meters, option B 0.03 meters, option C 5.00 meters, option D 2.50 meters. Now you must understand the relationship connecting the power and the focal length. Okay, and that relationship is what? The power is equals to 1 over what? F. Alright, power is measured in diopters, and in this question we are given as power to be 4 what? Diopters, right? They are asked to find the focal length, which is what we are looking for, simply by substituting into the formula by saying that 4 is equals to 1 over f. So we can say this is over 1 cross multiply, f is equals to 1 over what? 4, right? By the time you divide, I'm going to have 0.25 meters. So that is simply how to solve it. This question is just quite simple. And from what you have gotten so far, the correct option to this question is option A. I hope this video was able to help someone out there. Please don't forget to subscribe to this channel. Turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can watch this and learn from there. I will see you next time in the next one. Bye for now.